I am Pyojin Kim, an assistant professor at Gwangju Institute of Science and Technology. We call it GIST. Our group is to focus on some of the 3D spatial intelligence broadly, broadly for robotics. So we are working on the kinds of some visual navigation and SLAM and to make an impact to the world. Paper is quite simple that actually we first present some of the kinds of the first annotated dataset, benchmark datasets from the outer space, from the International Space Stations. And the reason why we developed and proposed this kinds of some dataset is some datasets obtained on Earth, but still they can only cover some limited scenarios and limited some motion patterns, some constraint to some drone or some mobile robots. But actually, we are currently working closely with some NASA Ames in the US. So while we develop the robust and efficient SLAM for the Astrobee, the free-flying robot on the ISS, so we just realized that we need the benchmark datasets. But the problem is there is no benchmark datasets obtained in the space, literally in the space. So that's why we this dataset is first we gather and we organize for our internal use. But we decide to release for some SLAM and robotics communities. So we realized that this kind of data set can inspire and can foster some of the advancements of visual navigation for some upcoming space robotics fields. So the biggest contribution is definitely we released and present some of the dataset, visual-inertial dataset obtained from the Astrobee operating on the ISS currently. They are working, so it consists of some camera monocular images, IMU measurements, and some of the ground truth pose of the camera. So based on that, anyone can download the dataset on the website. And anyone who is interested in developing some of the visual navigation algorithms for the space robotics can utilize the dataset. So, and the second contribution might be actually we also try to focus on to obtain some of the true pose of the camera. There is no motion capture system on the ISS, of course. So of course we also cannot ask some of the space crew members to install the motion capture system. So the problem is then how could we obtain some of the pseudo ground truth on this Astrobee on the ISS. So we just try to focus on that part. So we just kind of propose and generate the pseudo ground truth generation pipeline. We call just a bit modified version of the structural motion. So I think that is the biggest contribution of the paper, I think, yeah. One of the major challenges definitely we faced is how could we obtain some of the true camera pose. So the problem is that the benchmark should have some kinds of reliable true camera pose because any specific algorithm could be evaluated in not only qualitative but also some quantitative. So that's why we just try to focus on the pseudo ground truth generation pipeline. So we utilized our own sequential mapping and localization pipelines in an offline manner. Of course, actually, we don't have to run in real time, of course. At the end, we can obtain some of the almost true. That's why we call this pseudo ground truth, not that accurate like NOKOV Motion Capture system, but actually we also evaluate the estimated accuracy of the pseudo ground truth. So we conclude that the estimated accuracy is about 5 to 10 centimeters on the ISS. So of course we still try to improve the accuracies, but I think that's enough to evaluate the existing state-of-the-art algorithms on the ISS.